Okay, this next example here is very similar to a problem we did earlier. Once again, we have a bunch of e to the x's hanging around here. This time, I actually do have an e to the x on top that I could use to kind of address that guy's problem. So I do kind of have an e to the x up there that could address letting u be that, but then I still have this stuff here. So if I went to u right now and let u be e to the x, I'd have u minus 2 over u. All right, and then where do I go from there? All right, where do I go from there? What do I do next? Maybe you can think of something to do, and that's fine, and you could proceed that way. All right, letting u be e to the x. Instead, what I'm going to do is basically the same thing I started out doing last time, and that's realizing that e to the x to a negative can be rewritten as 2 over e to the x. And what that gives me is a complex fraction. And we can deal with complex fractions by multiplying by 1. Multiplying by 1. So both top and bottom by the common denominator. Excuse me. Excuse me again. And so we simplify. On top, e to the x would be e to the 2x. On the bottom, that'll give me an e to the 2x minus 2 dx. Okay. Now we can start to take care of things. What we can actually do here is let u be the whole denominator. Since the 2 is a constant and it won't contribute anything to the derivative, then you're going to have a derivative of e to the 2x, which is going to involve the e to the 2x that's on the top. And so we proceed as follows. Let u be to the e to the 2x minus 2. We differentiate. Remember, the derivative of e to anything is itself times the derivative of its exponent. In other words, 2e to the 2x dx. So we almost have everything we need to carry substitution through. We needed 2e to the x, e to the 2x dx. We have an e to the 2x, so we're just missing the 2. So we can go ahead and put the 2 with it. And what that'll do is require a 1/2 on the outside. And so then we'll have everything I need to carry the integration through, the substitution through. And the bottom will just become u. So that this problem would transform to 1/2 integral 1 over u du. But integral of 1 over u is just integral of 1 over u is just natural log of the absolute value plus a constant, and then we substitute back in for u. We'll get 1/2 ln absolute value e to the 2x minus 2 plus a constant. E to the x has a horizontal asymptote of 0. So when you do a minus 2, that will actually, for a while, drop the e to the x minus 2 function below the x-axis. So we can't drop the absolute value function here in this case. So you could absorb the 1/2 and make it a square root. In fact, that might be something the textbook might do, but it's perfectly fine as it is right here.